We are going to talk about the parts of a triangle. And so we've got three pieces we're going to talk about. The first piece is called the median. So median to me sounds like middle. And it is, to me, really important to make that sound connection in order to remember it. If you were in the SEL this morning, you talked about how to memorize things. And so finding those little mnemonic tricks, devices, different ways to think about stuff will help over the long run. So median is midpoint. Median is middle. The median in a set of numbers is the average of the numbers. So what is the middle, or the where people gravitate most towards? The median is that middle point, okay? So midpoint, so all I do is I go in any type of triangle, and it doesn't matter what the triangle looks like, any kind of triangle, I go from the vertex of the triangle to the midpoint of the opposite side. So you have to know that this is the midpoint by some distinction. Either it's given to you that it's the midpoint, or it is in the picture, it's shown that it's the midpoint. So this line right here is called the median. Median. Okay, that's the median. You're going to have to identify the median, and you're also going to have to use it in a proof. So if I tell you that the median, let's give this guy some letters, A, B, C, and D. So if I tell you AC is the median, then you could tell me that BC and CD are congruent. So BC is congruent to CD because AC is the median and it bisects the opposite side, or because it creates congruency. So you'll want that median midpoint idea. Median, midpoint. Okay, altitude. Now, I have a really dumb way to memorize altitude. If you've ever flown in a plane or watched a movie where someone has flown in a plane, they talk about reaching a certain altitude. So an altitude is the height that the plane reaches. So how do we measure altitude? And why does the plane call it the altitude? Well, the plane calls it the altitude because it makes a right angle with the earth. Where does the plane meet the right angle with the earth? So for example, let's say here's the earth. Well, you got to have a pen. Let's say here's the earth, and you've got your plane. You can laugh if you want. Here's my plane. Okay, there's my plane, and I'm flying above the earth. Now, if I were in the sky with lots of other planes, and there are thousands of planes flying at all different times at different altitudes, I know that if I'm at a different altitude than another plane, that I'm not going to crash and intersect. So having an accurate measurement of altitude is important. However, if we don't make a uniform way to measure altitude or to make that right angle, then we could be calling altitude all kinds of things. For example, if I said this is how far away from the earth I am, that's my altitude, and then someone else, another plane, is flying, and I'm actually at the same height as this other person, but they're measuring it maybe this way. Okay, so maybe it looks like we're at different altitudes, right? Because if this were a right triangle, this hypotenuse, this line right here, the green line, would be longer, right? So it sounds like we're not at the same altitude. It sounds like we're not at the same height, but we actually are because we measured it different ways. So the fact that we make that right angle is why I can use the word altitude to describe the height of my plane, because the altitude is where I intersected a right angle. Now, if I use the altitude here, I would say, oh my gosh, we are exactly the same height. We're going to run into each other. Okay, so that's my really weird explanation of altitude. But altitude, generally speaking, if you ignore everything else I said, it is where we make a right angle with the opposite side. And sometimes our opposite side isn't even inside the triangle. So you may have seen pictures like this before, where they draw the height outside of the triangle. This could be the altitude of the triangle from point A to the opposite side. So it doesn't always have to go to inside the triangle. It's just from any vertex to the in a triangle to the opposite side. We're going to talk about auxiliary lines. So an auxiliary line is a line that's not in the original diagram, but you draw it to help you. Now, guys, you can't draw auxiliary lines just wherever you want them. You do have to be careful about auxiliary lines and making specific choices about where they're going to go and what you know about them. One of the easiest places that we draw auxiliary lines are in circles. So, for example, if I have a circle and this is called a chord, so if I call this A, C, and B is here in the center, I might be told that B is the center of the circle. So remember, that's our notation for B is the center of the circle. And this is the only thing I have. And maybe I need to find some information about how long AC is. So what I can do is I can draw an auxiliary line. When we draw an auxiliary line, we dot the line. And maybe I'll draw two of them. Now, when I drew those lines in, they are radii. They're going to help me. So maybe I use that for the fact that the radii are congruent in my proof. When I draw auxiliary lines into a proof, I would write it in as draw AB and BC, like that. Draw A, B, and BC. And my reason here would be auxiliary line, or you could say 2 points determine a line. That doesn't make as much sense to me. I mean, it does make sense, but most people just write auxiliary line because it's shorter. So, or 2 points determine a line. Okay, so you could do it either way, but that's how you would add it into a proof if you were drawing it in. Now, you don't want to just draw in a random line and be like, here, I'm going to draw this guy in. Okay, well, it's not going to help me. Like, it's not going to do anything to have a random line over there. So we don't want to just draw in random lines that don't have any meaning. The reason I drew these particular lines is because they were radii, so that helped me in my whole overall process. All right, so we're going to talk about perpendicular bisectors. And perpendicular is a word that you should be familiar with, but you might not be. And we didn't really explicitly go over it in this class, so I'll take this opportunity to talk about it here. Perpendicular means to create a right angle. So it's two lines or line segments that create a right angle. Okay, and the symbol is this. It's an upside down T. So it'll be two lines or line segments or rays. And when it says two lines or line segments are perpendicular, it means that they make a right angle. So the word bisector, we already know, bisector means to divide into two congruent parts. Divide into two equal parts. Okay, so it takes it and divides it into two congruent sections or two equal parts. So when we talk about a perpendicular bisector, we're saying that it's not only perpendicular to a line, but it also divides it into two congruent parts. So, for example, if I said, let's see, we'll draw a little picture here. All right, so here's our little picture. X, Y, Z is a triangle, and I'm going to tell you that XW is the perpendicular bisector of YZ. So what that tells me is that it intersects, XW intersects YZ at a right angle, and it also divides it into two congruent parts. So a perpendicular bisector is actually both a median and altitude in the same sentence. A median and an altitude in the same sentence. Okay, so perpendicular bisector is a median and an altitude. It is both perpendicular, so it creates a right angle, and it bisects the opposite side.